Hi everyone, my name is Prashant Mohan Thakur and welcome you all to my YouTube channel Competition Valley. We are continuing the same topic, division and remainders as well. In this session, we will be trying to learn new concepts by doing some questions. Okay, so let's start over here. So find remainder. So you can write it 28 to the power 729 by 29 or 3 to the power 160 to the power 82, and you can take 7 to the power 105 by 344, and then you can also take 3 to the power 162 by 82. So we'll try to solve this thing. Okay. Now let's observe something. So for an example, let's try to divide 3 by 13. So what would happen? At the first look, it's very clear that this is not divisible because remainder is less than the divisor. Okay, but how can we prove this, that this theory is right? What we can do, we can simply divide it the way we do, and we can see that what we in the result will be getting minus 10 as a remainder. But we know that remainder can never be negative, so what we can do, we have to subtract these two and we'll have 3 as a remainder. Now what is the purpose over here of telling this method? That in such question wherein these numbers, the fraction looks horrible and it looks terrifying and scary, so we have to get this fraction, at least we have to get the numerator as close to the denominator, because numerator is dynamic. It can change because it has variable to change, but the denominator is fixed. Okay, so we have to ensure that the numerator gets as close to the denominator, because that's how it would be easier for us to simplify. That's the entire goal. So either we can do the normal process or we can do this negative way as well. So that's the entire trick over here. So in the first question, we see 29 and 28. So again, 29, and what we get is minus 1. So what we can say is minus 1 to the power 729. Now we should always remember three things. That first, remainder will never be negative. Second, minus 1 to the power odd is a negative term, so it will be always minus 1, and plus 1, minus 1 to the power even would be a positive number, that is plus 1. So these three things, so it will be minus 1. Second, 3 to the power 160 by 82. As said before, we have to get this numerator as close to the denominator. So either it should be 82, so it's 82, so we should look for 81 or 83. So 83 we cannot reach, because over here in terms of power of 3 we cannot reach to the 83, but we can look for 81. So it will be 3 into 3 into 3 into 3, so it will be 3 to the power 4 by 82. So what do we have left now? We have 81 by 82 again, which is minus 1 to the power even, which would be a plus. Now how we have done this? It's a basic identity. It's if it is a m to the power n, then it can be a mn. So that's how we can break it over here. Okay, so we have got these two things clear. We'll do the third one now. The third one is 7 to the power 105 by 344. Again, we have to ensure that this numerator would be in some form related to the denominator in the closest possible way. So 7, 7, 49, and 7 would be 343. So we can get 7 cube. Again, we are taking 3 out of this 105. So what would be left behind? We would be left with 35. And we have 344. So we have 343 by 344. And we have power 35. So we have minus 1 to the power 35, which is which is -1. So just focus over here. We're doing nothing great. We're just dividing it by breaking the division into the simplest of the form. That's what we are doing. We are using the concept of division, what we have known since we were a kid. So that's what we are doing it. Okay. So let's do the last one now. So last one here is 3 to the power 162 by 82. Again, our endeavor is over here that we should get close to 81. But over here, if we do 3 to the power 4, so we know that 4 would not be, so we'll get remainder as 2. So we cannot do anything over here. So what we can do, can we write this term? Why we are writing? Because 162 cannot be divided by 4 completely. So we would not have a remainder as such that 3 to the power 4 can be written over here. So what we are doing, we are trying to break this fraction again. So can we write 360 into 3 squared by 82? So again 3 over here, we can write this way into 82 into 9. So this part, again we know 81 by 82, this would be -1 to the power 40, so it will be +1, and we have 9 by 82. So 9 by 82, again 9 in itself is a remainder, so we would have 9 over here. So don't be under impression that only you would have -1 or +1 as the answer. It could be anything. You have to use the concept very clearly for that. If the number is not getting directly divisible, break it into this form because it doesn't make a difference. AM in into n can be written as AM plus AN. So that's what I have done over here. AM can be written as, this is what I've done over here. AM plus N can be written as. Okay. So this is what over here. That it's 362. So does an A into B, when it will happen, it will divide it. It will add up. Okay. So now let's go for a different concept and a different question. So again, it will be in form of question. So let's say find remainder 7, 7, 7 by 28, 8, 8 by 2 by, we can take 48, and then we can take 8, 8 by 2 by 72, and okay, this should be fine. So we'll learn concept as well from here. Okay, so now let's answer this. Now, before we answer this, now 7, 7, 7 to the power 7, 78, 28. So can it be written as 7, 7, 7, 6 by 4? Now look over here, what we have done. This is very important step you need to understand. This is 7 to the power 777 by 28. So we have cancelled the numerator and denominator by 7. Again, we have just cancelled it. Okay. So now we have over here 7 to the power 776 and by 4, and we need to find the remainder. Okay. Now we'll stop here for a moment and we'll try to see how basically a division works. Okay. What's the formula for that? Or what's the algorithm rather? So let's take 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So if we do so, what is that we're going to get? 117, 64, 52. You would have 12, 5, 117, 8, 6, 8, 7. You have 9, and then 9. Then you have 2. Let's say 2 is the remainder. 2 is remainder. Now, forget about this. It's not useful here. So what we need to see, look at the algorithm. The algorithm is that every time we are dividing a remainder by this divisor. See, 13 is getting divided again. 13 is is being used for division again and again. So what do we conclude from here? So can we conclude that in a division, denominator can be used multiple times, isn't it? It can be used. Let's say for an example, let's take in another example. So let's say for example, 4 into 8 into 2 into 9 into 5 by, let's say, if we get 72. So what are we doing? See over here. We are taking 9, taking 8. We are taking 2, we are taking 4. So denominator is getting used again and again and again till the time remainder is less than the division. Okay, now understand this concept over here, that denominator can be used again and again and again till the time remainder is less than the denominator or divisor, whatever you may say. It's the same thing because divisor is at the denominator's place. So over here we have this remainder because we did a multiplication. This is what we did a simplification. This is what we got. So again we'll be doing the division. So what would happen? We will get 3 as the remainder on the top, and then we'll be getting 4 at the bottom, and then what we are going to get over here is 776. Okay, now again we can use this, but we cannot use that because we know 3 is less than 4. So again simple, minus 1, 776 is 1. Okay, so the answer should be 1, isn't it? See, this is what we have done now. Those of you who have problem understanding this, I can simplify this further over here. So can we write this as this one? Then we can just take 4. So that's what we have over here. And then from here, what we did, we need remainder. So again, we divided this part over here, 4 into 7. So what we got remainder is 3. Okay. And again, we have denominator is 4. So now further, there cannot be any division because remainder is less than the division. So it cannot be. So we can conclude this. So this should be the answer, isn't it? But no, this should not be the answer. Why? Because at the beginning, we have used 7 as the cancellation factor. Cancellation factor. Because if you remember 7, 1, 7, 7 into 4. So we have to take 7, and now 7 should be the answer. So if you see in your answer sheet 1, don't just jump onto that. Okay. And now one more thing. See, the previous method, what we did, and this method is entirely different for different sort of questions. So you'll have to identify the question first. That was when we were trying to get the numerator as close as to the denominator. If you cannot do that, just simply jump onto this method. Okay, there will be so many other methods as well that would be coming further. So practice it. Watch the video again and again, multiple times. That would give you an easy way to find out what method has to be used when. So let's do this second question. So second is 8. This is second 8 power 52 by 48. Okay, so can we write this as 8 to the power 51 by 6? Again, 8 into 8 to the power 1 into 8 by 48. 6. Simple. We need to find the remainder. 6 to the power 8. It should be around 2, I guess. That's what should be the remainder. 1 by 6. That's how the remainder, that should be the final answer. We cannot conclude it from here anything. Okay, but this sort of question you will not get because this is practically unless this is provided in the option, you will not get it. Okay, because you will get only those questions which would have certain concepts behind it. They will not give you any arbitrary number or any random number out of box, out of their whims and fancy. So there would be always any questions, whether you see in CAT, CSAT, any examination, GRE, GMAT, it has certain logic behind it. Okay, so don't ever think that you are going to get anything which has no useful concept behind it. So now we'll be doing the third one. Third one is 852 by 72. So the first step, now do this with me, okay? As far as you can go, that's fine, but that would help you to understand in much better manner. So we can write this as 9. Again, 9 is minus 1 into 851, which is minus 1. But this cannot be a cancellation factor, as said before. I'm sorry, this cannot be a remainder because this is a negative term. So what we would have to do, we have to first we have to make sure it is positive, but before we do that, we have to check what would be our final remainder. So we know that the cancellation factor is 8, so it should be minus 1 into 8 is minus 8. Therefore, remainder would be 72 minus 8 is 64. Okay, the simple concepts. Remainder can never be negative. Simple concept. If we are canceling the numbers, again, if canceling the fraction, make sure to multiply the cancellation factor by the remainder. Very important. Don't miss it. If you miss it, you're gone. Dead. There's nothing that can be done. Okay. So I hope this concept would be clear to you as well. Okay. So now let's move for the last section of this video. Let's do the question now. Okay. A prime number b greater than 100 leaves a remainder q upon division by 28. How many values can you take? That's the question. Now this question may look quite difficult for some of you, but it exactly isn't difficult at all. This is a very plain, simple question. The numbers have been twisted, the wordings have been jumbled up, but it's a plain division question. You'll see how. So it says 28, then it says P, and then it says Q. These are the things given over here, where Q is remainder. So if Q is remainder, it means there has to be a quotient as well, so we can consider N as a quotient. So therefore, can we write dividend equal to divisor into quotient plus remainder? Can it be written? Okay, fine. So it means we can write 28N plus Q. Now what's the question? It says how many values Q can take. Okay, so let's start with. Now, before we start looking for Q, we also know that this portion is even. How do we know that? Because 28 into N, any number for any value of N, 28 N is even. So that's for sure. Also, we know that even plus even will not be prime. So we prime. So we also know that the value of Q, therefore Q has to be odd because this is even. So it has to, that's what we have left. So this has to be an odd number. Okay. So now we can start with Q equal to 1. So if we do Q equal to 1, so can we see if any situation arises wherein if we take Q equal to 1, this entire 29 plus Q can be divided by 28? No, I don't think so, isn't it? 20 for any value. Let's say we take N equal to 1, so we have 28 plus 1, 29. It cannot be done. For 2, again, it cannot be done. It's 57. So we see that for any value of N, 28 N plus Q cannot be divided. So since it cannot be divided, so we can consider that might be this is a prime number. So this is one case. The second case, we can take Q equal to 3. So again, if we take Q equal to 3, are there any number that satisfies this equation wherein this entire number can be divided by 28, so it also can't be divided. Okay, so we take q equal to 5. We see again 28n plus 5 can't be divided by 28. Again, we check for q equal to 7. So we see that 28 plus 7 can be divided by 28, isn't it? Look over here again. Let's check this fact. So 28 into 1 plus 7. What do we have? 35, which is divisible by 35. 28 into 2 plus 7, which is 63 by 7. 28 into 3 plus 7, which is 91 by 7. So we are very sure now that 20n plus 7 will be divided. So we cannot take that. So you cannot take that. So now we see that there is a certain pattern over here. The pattern, if we try to generalize it over here, we see that any factor of 28 won't be counted, isn't it? Look away. We try to okay. So what we have seen over here is that for any number of for any factor of 28, okay, so let's say we check this for 7 and we found this to be true. So can we check it for 40, let's say 14 not, can we check this for 21? Okay, because 21 is again 7 into 3, so this situation should not be satisfying our condition. So 28 into 21 plus q is 21, so we can take 21. So 28 to 88 plus 21, let's say we could have done other way as well. It's much complicated. We have q equal to 21. That's what we say. We need to check the equation. 28n plus 21. So for 1 it will be, so we see that 7 comes up over here, so we cannot take this as well. So it means that all the factors, that's what we can generalize of it. If we try to generalize it, what would it mean? Now what we have seen over here, that q can take 1, 3, 5, 9, 11, 13, but it has not, but q has not taken 7 or 21. So what we can generalize over here is that q can take all values which have no common factor with 28, isn't it? That's what it's doing over here. 7 it has, so it's not taking. 21 it's not taking. So also can we write it over here that q is all numbers co-prime to 28, isn't it? So how many numbers would it be? So 1, 3, 5, 9, 11, 13, 15, 17, 19, 23, 25, and 27. So if you count it, 3, 3, 6, 3, 9, 3, 12. So the answer is 12. Now this is a lengthy process. I understand it generally takes a long time. So what we can do, we have another way to do this as well. Now I was doing the first way because just to explain you the concept. Now we have a different way to do this as well. So what we can do is, second step will be, there's a basic formula for this. Okay. For all all the numbers that are not co-prime, we can simply do it in just one step. I'll tell you how we can do this in method 2. Method 2, it says a prime number precurrent leaves a remainder on division of by 28. How many values it can take? So 28 factor is 2 into 2 into 7, sorry, 7, or 2 square into 7. Therefore, numbers which would be co-prime to 28 will be 28 into 1 by 2 into 6 by 7 is 4. Co-prime to 28. So it should be 7 to 14 should be 2. It should be 12. Simple. That's the answer. Because we know we need to take co-prime. Now, how this has happened? Okay. Now, this is again a good question. How this has happened? All of a sudden. So let's see this now. How many numbers in 1 to 30 are, let's say, are divisible by 3? So we know 10. How do we get to know that? 3 is 10. Now, if we say how many numbers in 1 to 30 are not divisible, so what we do? Again, we check how many of, so what we can do? 30 into 1 by 3, 30 minus. So 31 minus 1 by 3, or 30 into 2 by 3. So 20. This is what we would have done. This is exactly what we have done. But by increasing your mental speed, you can just simply do it. You do not have to do these steps, these steps. Simply look for the factor. If it's 2, so 1 by 2. If it's 7, 6 by 7. Had it been any number 5, so it would be 4 by 5. Simple step. Okay. Let's do a couple of questions on this as well. Find all the co-prime of following number: 42, 422, 39. You can take 100. Okay, let's start. So 42, what's the first step? Try to take the factor. So now whatever you have as the factor, just 42 into 1 by 2 into 2 by 3 into 6 by 7. So you have 7, 3, 21, 42. So the answer is 12. Simple. What 422 if you want to do? So it's 42 into 10. So 2 square, I believe, into 3 into 7 into 5. So 4. So you have again 420 into 1 by 2 into 2 by 3 into 6 by 7 into 4 by 5. 2 to 4, 4, 16, 96. For 39, if you want to check with 39, again the factors 3 and 13. So simple. 2 by 3 into 12 by 13. 13, 24. It takes less than a minute. Even in seconds, you may say. 100, if you say, 100 is 2 square into 5 square. So 100 multiply 1 by 2 into 4 by 5, 10 into 40. Answer. Okay. Now this process is very much used of. So try to get habit of this process. Okay. Because the last question, the long process I did, because I wanted you to know how the concept works. Okay. By the way, the last question, if you have been able to do it, that's very good, because that was a CAT question. So if you have done it, means you are getting the concept very clearly. Okay. So we're stopping over here, and in next class we'll be raising our level once more. So thank you for watching this video. Once again, my name is Prashant Mohan Thakur, and you were on Competition Valley. Bye for now.